In this video, we're going to focus on hydrocarbons. So what basically is a hydrocarbon? Methane is a hydrocarbon. It contains only carbon and hydrogen atoms. Ethane, C2H6, is another type of hydrocarbon. Now you have aliphatic hydrocarbons, and you also have aromatic hydrocarbons. So what is the difference between the two? Aliphatic hydrocarbons include carbons such as alkanes, molecules such as alkenes. Alkenes possess carbon-carbon double bonds, and also the alkynes. These are all considered aliphatic hydrocarbons. An aromatic hydrocarbon, the most popular example, is the benzene ring, which has 3 alternating double bonds inside a cyclohexane ring. This is also known as an arene. Now you also need to be familiar with saturated and unsaturated hydrocarbons. So what is the difference between a saturated hydrocarbon and an unsaturated hydrocarbon? Saturated hydrocarbons are basically alkanes. They're completely filled with hydrogen atoms. They have the maximum number of hydrogen atoms per carbon atom. So anytime you have an alkane, you have a saturated hydrocarbon. There are no double bonds, only just single bonds or sigma bonds. Unsaturated hydrocarbons include alkenes, whenever you have a carbon-carbon double bond, alkynes, those are unsaturated, and even a benzene ring, that's another unsaturated hydrocarbon. So anytime you have a pi bond, so if the molecule has any double bonds or triple bonds, it's an unsaturated hydrocarbon. If it only contains single bonds, then it's a saturated hydrocarbon. So make sure you understand that unsaturated hydrocarbons include alkenes, alkynes, and aromatic rings, and only alkanes are saturated. Now let's talk about the alkanes, the saturated hydrocarbons. The general formula for an alkane is CnH2n plus 2. So the first example is C1H4. So this is known as methane. Next we have C2H6, and this is called ethane. C3H8, this is propane. Now in most organic chemistry classes, you need to know the first 10, so up to C10. C4H8, if you have 4 carbons, is going to be called a butane, and C5H12 is pentane. C6H14, if you want to write it down, that's hexane. C7H16 is heptane. C8H18 is octane. C9H20 is nonane. And C10H22 is decane. Now for those of you who need to know the first 20, here it is. So C11H24, this is known as dodecane. And C12H26, that's, actually I take that back, C12 is dodecane. C11, this is undecane. C12 is dodecane. C13, that's tridecane. C14, tetradecane. C15, pentadecane. C16, hexadecane. C17, heptadecane. C18 is octadecane. C19, I'll write this one down, H40, this is nonadecane. So you can see a pattern. If you think about it, nana is 9, decane is 10. If you add it, you get 19. So going back to C15H32, we said that was pentadecane. So penta, we know, symbolizes 5, decane is 10. 5 plus 10 will give you 15. And the last one, C20H42, this is called icosane. And I got no tricks for you for that one. Now let's talk about alkenes. Alkenes have the formula CnH2n if they only have one double bond or one pi bond. For each double bond that's found in the alkene, you need to decrease this by 2. So if there's like 2 pi bonds, it's going to be CnH2n minus 2. But if it only has one double bond, this is the general formula for an alkene. So for instance, this is 2-butene. And if we were to draw out the structure, it would look like this. This is particularly trans 2-butene. If it was cis, the two methyl groups would be on the same side as opposed to opposite sides. Now, if you count the number of carbon atoms, 2-butene has 4 carbon atoms, and there's 3 hydrogens here, 6, 7, 8. So it's C4H8. So in this case, N is 4, which means that 2N, or 2 times 4, is 8. So alkenes have that general formula if they possess one double bond. It turns out that cycloalkanes also have the same formula, CnH2n, if they have one ring. If they have 2 rings, then it's CnH2n minus 2. So just keep that in mind. This is for one ring, and this is if they have 2 rings. So a good example will be cyclopentane, C5H10. Now, carbon can only form 4 bonds, and every carbon atom is attached to 2 other carbon atoms. So there's only space for 2 hydrogen atoms on each carbon. And so in this molecule, we have a total of 5 carbon atoms and 10 hydrogen atoms. So it's C5H10. Now let's compare this to a typical alkane, such as pentane. Pentane is C5H12, based on the formula CnH2n plus 2. So alkanes have the maximum number of hydrogens per carbon atom, and so they're saturated. But anytime you add a ring or a double bond, you lose 2 hydrogen atoms. And so that's why alkenes are unsaturated. They don't have the maximum number of hydrogen atoms that they can have. So whenever you have a ring or a double bond, you lose 2 hydrogen atoms. If you have a triple bond, you will lose 4 hydrogen atoms. So in the case of alkynes, they have the chemical formula CnH2n minus 2, assuming we have a molecule with 1 triple bond. For every triple bond, you lose 4 hydrogen atoms. So let's look at acetylene. This is C2H2. And if we compare it to ethane, which has the same number of carbons, this is C2H6. So notice that the difference in the number of hydrogen atoms is 4. So let's look at another example. This molecule is called 2-butyne. If we draw it, it looks like this. So it's C4H6. Whereas if you compare it to the alkane butane, which is C4H10, you'll see that there's a difference in 4 hydrogen atoms. So anytime you introduce a double bond or a ring, 2 hydrogen atoms will be lost. And if you introduce a triple bond, 4 hydrogen atoms will be lost. And so I want to give you a basic introduction into hydrocarbons. And they're basically molecules that contain just carbon and hydrogen in it. So that's all I got for this video. Thanks for watching, and I guess I'll see you in the next video.